And here we go. Let me first introduce myself. All right. Hello, everyone. I am Mathieu Duchemin, but you can call me Matt, is way easier. I'm a consultant and a support engineer at Potix for the ZK framework and the other product that we provide. And today I'm going to be telling you about the new ZK10 stateless components. This is going to be a free-form talk mostly about the architecture and the reason why those components exist. We're also going to have a small technical presentation where I'm going to show you the type of use case we have in mind for those components and how we expect people will be able to use them to create application on their own and for their own need. So let's jump right into the use case. So before I can talk to you about the stateless component use case, I'm going to have to do a short overview of the classic architecture which most ZK projects in the old time would have been created for. So this is going to be very basic. Please be patient with me. I promise it's going to be very short. So in the classic use case, you would have your web server. Maybe you will have a single web server, or maybe you will have a cluster of web server. Those web servers will be accessing a data layer, which will be either a database or maybe a REST API on your enterprise business layer. It can be anything, anything that is not just providing web service and is providing data to the web service. And then in front of your web server, you're going to have all of your middleware, your gateway, load balancer, reverse proxy, everything that transmits the request from the client to the web server. In this situation, the end user simply goes through the internet, access the entry point for your architecture, is being directed to one of your web servers, and then receives a page. Very simple. That ZK page in the classic architecture exists in memory on the web server. You will have a number of objects which are all located in the session. And those objects in the session will contain the page, the components of the page, and the state of the component that are located in this page. So whenever an update is requested by the client, essentially essentially the page state will be in memory at server side. And once the user requests the page, an update from the state that exists at server side is being sent back to the client to synchronize the client state with the server state. But the master state is located on your web server. If for some reason one of your server goes offline, or if you add more server because you have a lot of users connecting at the same time and your server are being overloaded, if the session need to move from a server to another, it is possible in that classic use case, but you have to move all of that state in memory from one server to the other. That can be done with session replication. For example, Tomcat session replication is the go-to use case for this situation, but you want to avoid it because it's a somewhat expensive process. You don't want every single user request to trigger a session replication event and then do a fallback. So in this situation, you would have sticky session enabled, and you would try to maintain for a single user client a connection to the same server to avoid having to exchange that data from server to server. If we do a quick review of the attribute of this architecture. We're going to see the 3 layers that I was mentioning in the beginning. First, your middleware, all of your network stuff, your gateway, your load balancer, your proxy. Then your web servers, either single or cluster, and then your data layer. You will see that in this architecture, you do session-centric development. You will assume that you have a session object that will stay the same for every operation that your individual end user is going to perform on the page, or even in the larger session that may contain multiple pages. This is powerful because you have a single session object that can contain all of your data that you can refer to between operation in order to retrieve a state at server side. However, it is less flexible than the next use case we're going to see, the stateless use case, because you need to do session handling. That session object has to exist, it has to be replicated, it has to be shared by every single server in your architecture, or at least it has to be accessible in the event that another server need to take over and be the main interlocutor for that specific user. Now, the stateless use case, what we're trying to achieve with the stateless component in ZK10. We're assuming that the architecture is similar, but not quite the same. You will still have your network layer, all of your middleware, your load balancer, your gateway, but it might be more complicated than that. You might be on a hosted platform, which you do not control directly, where this middleware is abstracted to you. You just know that eventually requests are going to reach your web containers. You will still have a database layer or a data layer, which you access from an API. And this one, we're not going to focus too much on because it's not the domain of ZK. ZK itself is agnostic of the data layer. We don't care where the data come from. That's a data layer question. So that's something you handle with your database admin or with the person in charge of your business API. And then you have in the middle the abstract web layer. I call it an abstract web layer because you don't necessarily know where everything is or how everything exists on an individual container level. It might be that you have a single server that is running Docker images, and you might be spinning up server or spinning down server to match the user activity on your website. Maybe you need to increase the number of nodes because every server is overloaded, or maybe you need to decrease it because now there's few activity and you want to conserve resources. Or if you pay for those nodes, you maybe need to spin them down in order to reduce the costs. Maybe you're on a hosted platform where you run those nodes on a third-party server or on a business provided container. In any case, those nodes might not be able to know about each other. You may have a number of unique nodes separated from each other. You may have a number of clusters of nodes that can talk in their local cluster, but are separated from other clusters. This can be the case for any number of reasons. Maybe you do high availability locally. Maybe you do high availability on a global scale where you will have containers for major regions. Maybe you simply have different type of services running in different clusters that shouldn't know about each other because they're not in the same functional domain. The end result is you have a lot of possible entry point for the user actions, and those entry points are physically and logically separated from each other. If you have a user request coming on to a specific server on a specific local cluster, and you need to fall over that request on next user action to another server in the same local cluster, you might be able to get away with this if you're using session replication, simply by having those local server in a cluster be able to communicate to each other. However, you will very quickly run into issues if your user is routed to a different cluster, or if you have an extremely large number of nodes or large number of users. Essentially, at this scale and in this type of architecture, replicating a user session becomes difficult, either for performance or for architecture consideration. So what do you do in this situation? Essentially, you do not have a session. You do not have a state. You only work in terms of workflows. So what are the attributes of that architecture? You have your middleware, you have your data layer. In the middle, you have an abstract web layer, a web layer that does not contain a session and will only deal with the end user in terms of workflows. You don't have a user session on purpose, so you do not need to replicate it. You do stateless development, and therefore you will be concerned about incoming data and outgoing data, but not in terms of state. You do not maintain a state at server side that you then synchronize to the client. You simply take a number of value from the client on a specific workflow and then return a result based on that workflow. No session means no session handling. You do not need to care about session replication. You do not need to care about session permanence or about exchanging data between your different servers. You only need to care about what data goes in at any given time and what data need to go out. This is a more flexible deployment, because since you don't need to have those session configuration, you can skip a lot of data replication, as I mentioned. The cost of that flexible deployment is it requires stateless workflows and stateless development, which we're going to discuss during the technical demo in a few minutes. Let's go to the next slide. So, general questions before the Q&A, things that we expect people to ask. Why are we creating stateless components? What is the reason for that effort on our part? Simply put, we have noticed that modern use cases are not always well served by the existing ZK Classic component. When a developer needs to use a lot of smaller size containers, when they need to use a third-party platform in which they don't really have control over the data replication, or for a number of other modern infrastructure use cases and needs, we want to provide a way to use ZK components. So the classic ZK text box, layout, list box, divs, everything that you're used to be able to leverage in a classic ZK page in an environment where you also don't need to worry about maintaining the state of those components at session level. The next question would be, is stateless an upgrade to classic ZK? And I have to be very clear here to avoid confusion. It is not an upgrade, it is a branching technology. Classic ZK relies on the session. The page is in memory as an attribute of the HTTP session that exists on your web container, and the component live in a page and you synchronize the state with the client. Stateless is a technology that allows you to use the same ZK components, with the main difference that it does not need a session. And those components can be used to create a page with the same end result. You will still see the same component from the user point of view, but with a different technology on server side that is meant to address different infrastructure needs. Do I need to migrate my existing application to stateless? Yes and no. There's not a one-size-fits-all solution here. If you are developing an application reliant on microservices, if you're developing an application that is meant to be deployed in cloud containers that you do not own, but you rent, for example, from a large company that provide hosting services. If you have a development pattern where you want to do UI composition with multiple individual services that don't need to know about each other, in all of those cases, stateless component would be a useful tool because you will be able to skip a lot of infrastructure requirement and focus on a more flexible deployment, flexible way to create those pages. However, if you have an existing application that is meant to be run on a classic server stack where you will have your Tomcat cluster or your Wildfire cluster or any other web container cluster with your database cluster in front, in the back, and your middleware in the front, and you don't expect that you will need to move to a flexible deployment, I would say you don't really need to do the effort to move to stateless. It would be it would essentially be wasting time, because if your application is already well suited to your infrastructure, you essentially do not need to do the effort to make it well suited to a different architecture, which you're not going to use anyway. So it is not necessary to upgrade your application to stateless. Simply consider what your infrastructure need is and decide if stateless is best for you or if classic infrastructure is best for you. Can I mix stateless components and regular component in a page? So this one is going to be a little complicated as an answer, but try to bear with me for a minute. You would not want to mix in a single UI element ZK component, classic, and stateless component. However, you could compose a page which uses different page element coming from different services. And I'm going to switch to a small sidetrack page. This is not really about stateless component. This is about page composition, but I need a visual aid to make that clear in a way that makes sense. Okay, so in a classic, a standard page call, not necessarily ZK, mostly every single page that you would get from a server in the 2000 and something, you would do a server request and the server would send you some code back, code which will be HTML, JavaScript, CSS, maybe other things. And you would have that single request, that single response. You will get your whole page from that request. Now, in page composition, what you can do is receive from your initial call a page with a number of empty elements, and those empty elements can be filled by different services. In ZK context, you can do this with a number of technologies. ZK embedded technology lets you embed a ZK page in a non-ZK container. But you can also do this with iframes or with other composition option depending on your infrastructure and your need. So for example, if I have a simple page, I could bring my header information from a first service. I could bring my user login box and my user feed from a second service. And I could bring my user main content from a third service. So those three services, if I include their content in iframe, for example, in this case, don't need to know about each other, and their output can be different technologies depending on what you need to do. For example, your header might be coming from just a static content service. your user login and password and your user feed might be coming from a user service that use stateless component because you expect high activity and you want to be able to spin those up and down on demand. And then your main page content might be coming from a classic ZK page or just any other source. And in this case, you would have your stateless component being used in those two container in your page. And you would have, for example, here, a main page created in classic ZK components. That's composition UI. It's a bit out of topic, but it is related to the type of use case which we expect to see with those stateless components. So I'm not going to do a technical demo about that. If you're interested, I suggest that you look for UI composition in general or for the ZK embedded, which is a feature in ZK 9 and forward. Okay, let's go to the demo shortly. But first, a word about what you're currently going to see from the code. This is a technology that is currently being created. There might be some differences between the final product and what you're going to see today, either because we will improve on some of the point or because we will receive feedback on other elements, or simply because we will find that there are a better way to arrange the different pieces of that feature. So keep in mind that while what I'm going to show you is a representative image of the final product, it is not the final product, and there might be differences from here to there. All right, let's get going. I'm going to turn off the presentation for a moment, and we're going to go to the code. So first, a quick view of the architecture which I'm using for this demonstration. This demonstration is a simplified version of an existing project, which is the ZK10 stateless component demo, which was released as a small talk about a month ago. And the code for that small talk is already available on GitHub. And at the end of this presentation, I will also give you a link to retrieve the code from the presentation that I'm going to show to you today. So you don't need to take screen capture or try to take notes. You will have the code available at the end. So what do I have locally? I have a Docker container. For those who are not familiar with Docker, Docker is a software which lets me easily spin up and spin down containers for different services. So in my Docker, I currently have all of those services running. I have a Postgre SQL database, which is used by the original demo and which I will not be using specifically in that simplified demonstration today. We have an Nginx, which is a proxy server, which is there to receive the request from the end user from the web browser and to dispatch them to the different Tomcat server that run on my container. And I also have 5 different Tomcat servers. Those Tomcat servers don't know about each other. They're in the same local virtual network. So I could have session replication, for example, set on them, but it is not currently configured. For the purpose of that demonstration, you can consider that all of these servers are individual nodes that don't know about each other and are running on different ports on my local machine. All right, let's take a look at the code. So this is what you would expect to see when you create a page with the stateless component. Stateless pages are extension of richlets. It uses richlet technology, which is fairly similar if you've ever used Spring MVC. You simply tell which mapping you want to bind your service to as a URL. So in that case, I've bound my service to my local server /simple. And then inside of that service, you may have a sub URL. So in that case, I'm on an empty, quote unquote, mapping for my main page index, but you could bind other lists of components as different subpages. So what is a page when we create it with stateless component? A page is essentially the same thing as you would create in classic ZK, either from Zool or from Java code. It's a list of components that is being added to the page root. Stateless components have a bit of coding sugar that makes page declaration easier in Java code. For example, instead of creating a new style component, as I would do in classic ZK, and then assigning value to that style, in classic ZK, I would do stuff like this. I would say my style.set src, etc., etc. And then I would add that style to my main UI, to my container. In this case, I can simply create an iStyle of. The of something attribute is a coding shortcut, which will let me generate an iStyle stateless component based on one of the more the main properties of the style component, which in this case is an src. And this statement in itself represents a new iStyle component, which can be immediately added to the list of components in my page. I will, in addition to that iStyle component, I will create a vLayout off, and off in that case for vLayout, let me declare children. So all of the content of my off statement here is just the children's of my vLayout. In my vLayout, I will have an I label and an IH layout, which itself will contain a number of elements, etc., etc. As you can see, the logical structure of the code is very similar to the logical structure of the resulting page, with each element being essentially in the same place as you would expect an element to be in Zool if I was creating that page as a Zool file. This architecture also supports templating. So in this case, for example, I know that I'm going to create 3 different edge layout containing 2 label elements. So instead of just typing all of those elements one by one, what makes more sense, since I'm working in Java code, is to simply create a method that would generate this small block of UI, which is just an I layout containing 2 I labels with some properties, and then simply call my method multiple times with different parameters in order to generate those 3 UI elements as I would do with a template in Zool. Now, the last important concept to grasp on the stateless elements is that we do not have event listeners in the classic sense. We have actions. It is mostly the same, but there is a few little difference, and we're going to look at them very quickly. When I declare an action, I tell the withAction method which actions I want to register on my element. I can register a single action, which is what I did in this case, but I could also register multiple actions for on click, on change, on blur. There's all of the events that you're used to manipulate in classic ZK architecture are still available. They're just in the form of an action. And if we go to the input update action, which is this method over here, you will see that the action have an action type, which is the events that will trigger the action. So in this case, my element is a text box, and it has an action input update. That action input update is of type onChange, which means that if the user action in the UI were to trigger the onChange event, I would then trigger the input update action. And that input update action, to go on the last important concept to understand from the action, has variables. Action variables with instant. I'll take more question at the end of the presentation, but since I'm already on the code, I will answer that one immediately. With instant is simply the instant property of the text box. Regular ZK text box that you can use in any ZK application that you have already created have the instant property, which means that instead of waiting for the end user to click away from the text box, we will send the onChange value immediately or almost immediately when the user stop typing. And that's actually, since you're asking that question, I'll jump on it to show another thing. You don't have only with instant, you have with a number of properties, which is every property that you would expect to see on the relevant components. So a regular ZK text box has the constraint attribute, which means that the I text box, the stateless text box, have a with constraint. The regular ZK text box have a control keys attribute, so the I text box has a with control key, etc., etc. I'm not going to tell you what every single possible attribute is for every single component. I think that would not be a very good use of our time, but you can expect to see, if you look at the ZK documentation for a specific component, if you see this component support attribute A, B, and C, you will have a with A, with B, with C corresponding method on the I components. All right. So yes, I was talking about the action variables. Those are very important. I mentioned during the architecture part that the stateless component, by definition, do not keep a state at server side, which means that if you want to make modifications to the page based on the current state of the page, what you need to do is to retrieve data from the page, check what that data is during your workflow at server side, and then do something based on that data. Since the data does not exist at server side, you need to tell the action what type of data you need to retrieve from the state which is currently at client side, and use that state that you just retrieve to perform your actions. So in this case, what I'm telling the input update action to retrieve is target ID self. I'm targeting the component that triggered that action, and is field value. Hello, can you still hear me? I believe my headset has gone dark for just a second.
Yes, we hear you.
Thank you very much. Yes, so you need to tell the input update which value you want to retrieve, because you will need to use that value in your workflow. In this case, self is myself. So the component that hold the action is, for example, this text box, if I am triggering this specific instance of the input update. And the field, which is the property of the component that I'm targeting. In this case, this is text box value, but it could be a checkbox checked property, or you could retrieve other things. For example, selected status, any property that you would be able to query onto a regular ZK component by doing text box get disable, text box get value, text box get placeholder. All of those things you would be able to retrieve with your action variable. And of course, you need to retrieve every single variable that you're going to use in your workflow. If you take a look at the send form data action, you can see that in this case, I'm retrieving more than one property from more than one element, I component in this case. And I'm targeting those not just by self, but also by a target ID. I could also target them by relationships, for example, parent relationship or next sibling or first descendant. All of those relationship in the page are also valid. And there are more advanced way to use this. However, since this is a basics session, I'm going to keep it fairly simple. I will note that there is a more advanced version of all of those workflow that exist, which is the demo richlet, which exists on the ZK10 shopping cart demo, already available on GitHub and in our small talks. I will provide links at the end. This project is based on that original demo. So if you get this specific project, you're essentially getting both of the demo at the same time. Okay. So what else have we not talked about? We have talked about how we create components, how we assign the actions, which are essentially listeners to those components. Now, the last thing we need to care about is how do we modify the page in response to a user action. In order to modify the page, since we don't have a persistent page element, we don't have components existing at server side, what we need to do is to locate the target that we want to update or create or modify at client side using a locator. There are a number of options for locator. In this case, I'm using a locator of ID, which means that I'm going to find a component by its target ID. But you could create locators for other options. You can create a locator by relationship to other components. You can create locators by class, by type. Again, I'm going to stay very simple here, but you will find more advanced version of all of those workflow in the demo richlet if you look at the code later. Once you have a locator, this is essentially painting a target onto a specific I component, which exists already in the page at client side. You need to do something to that component. So you will use your UI agent, a new utility class, which lets you modify the stateless component at server side, and you will trigger an update. In this case, we're going to trigger a smart update on a locator. So that's whichever component we're targeting. In this case, we're targeting an I label. And we're going to create an updater. Updater is do something at client side action. I want to say factory, but it's not a factory. It's essentially telling the client that we want to find an I label. And on that I label, we want to update the value field. And the value field will have essentially the same action as doing label set value in classic Zool if you were working on classic ZK. And you could use an I text box updater to set placeholder. You could use a H layout updater to change the children of your H layout. All of the UI update actions that you would usually do from Java code, you're going to do them instead of targeting an existing component by providing a locator and then providing an action you want to do on that component once it has been located. Okay, I hope that was clear enough for now. We're going to go to a quick visual demonstration of what this would look like in a real browser situation. So let me jump to the web browser for this page. As I said, this is an extremely simple demo. I only have my 3 text box here, which are my 3 iText box created over here in my main V layout. And inside, below those 3 text boxes, I have my display label templates, which are just a label plus an active I labeled, which I can query, which are located here, here, and here. And at the end, I have my I button with my send from data action. So the first thing you're going to see when I modify the content of the iText box is that I would trigger the input update. I see that there are questions in the chat. I will come back to that at the end during Q&A, unless it is very specifically relevant to the code that I'm currently presenting. Okay, so my iText box, as I said, have an action. When I modify when I modify the content of my text box, you will see that my actions are being effected, sent to the different server nodes. And if you look here at the bottom, you will see that a random node in my available Tomcat servers is going to receive each of my page update actions. If I type more data and I see some updates happening to my UI, I can also inspect what has been sent. So if you're looking at the input update action here, you can see that the input update action takes an action variable, so a single variable from the client side. Sorry, my apology, 2 actions, two variables from the client side. We have the value and we have the ID. And then does something. So if I look at what is being sent to the server side from my client, you can see here the arguments being sent to my server side are the 2 arguments that I have requested in the action variable definition of my method. And in the response, I'm going to try and show you. Okay, here you will see that we have first this log value. This is just showing you what's happening here. It's not relevant. And we have set attribute with our locator here targeting an object at client side and setting a value, the field that we're modifying, with the value that we're setting, that attribute that we're adding at the end. So if you consider where the data is coming from, there is no data saved about the page. There can be any configuration of that page existing at client side. The page will send all of the necessary data to process a specific action when the action is triggered, and the action is going to send all of the specific information required to update the page as a result of that action. Once I have my 3 elements here filled, and I'll just take a moment. We were talking about the with property earlier. You will notice perhaps that the first text box of that demonstration has a with constraint no empty. If you've ever worked with a constraint on ZK text box, regular ZK text box, you will know that this means that I am controlling for the fact that my text box cannot have either an empty string or a string that is only created using spaces. That means that from a client side point of view, my client side elements still behave exactly as you would expect a ZK classic text box, which has been set with the same properties. Oops, okay. All right, so now what happens when I click on the send data button? When I click on the send data button, I'm going to trigger the last action that I have created here, which is the on-click action. The on-click action doesn't really do anything here at server side. It's just making a log of data, but this is to show you how the different fields that I will be receiving are retrieved from client side at this stage. Those fields don't exist in memory as in server side, exactly the same as the previous action. When I trigger this action, I want to retrieve the value from the first text box user ID, the value from text box user display name, and the value from text box user password. And this is what happens when the data is sent. I will see a payload in my data being sent, which contain all of my 3 arguments coming directly from the page. So exactly as before, the state is not kept at server side. The server side only has workflow, which accept different input data and will provide a result based on that input. All right. I believe that's most of it from the technical demo at the moment. I'll point out that, again, in the same project, you will have this more complex version of the demo, which contain list boxes, which contain complex component, which contains more complicated actions. If you have to if you're interested in a more complex version of what I have presented today, I strongly recommend that you start with that demonstration in the same project. Okay, so let's go back to the presentation. Now that we have finished this technical demo. So as I mentioned, all of this is going to be available on GitHub. I'm going to be sending a link in the chat, which you can access directly if you need to. You can clone this demo. There is a README file that explains what you need to do to create a Docker container in order to run it. And that should be enough for you to start and change the component in these pages, or simply create your new page to see how those behave. Okay. I hope this was interesting and informative. I would recommend, I would ask you to provide feedback to us. As I mentioned earlier, this is currently a very much in progress technology. We would absolutely love to hear what you have to say about those components, about the ID behind them, and whether or not you think those components would be useful to you, to your different use cases. And if you have any question, if you want to provide any information or other, please get in touch. I've sent a link to the feedback form for today. I've also on screen the info@zcos.org email in case you want to send us direct emails. All right. Now, let's get into question and answer. I've seen that there are already some questions in the chat, so I will start at what has been already asked. And then if you have further questions, we can take them one by one. Okay, so can we have stateless component out of Java and part of ZK page, or only via Java code that install? What is the real difference between stateless and client MVVM? Okay, client MVVM and stateless first, because that's the easy question. They're essentially opposite approaches to the performance slash processing at client situation. So client MVVM, the main concept is that some of your data structures do not need to be processed at server side, but you still have a server-side state, which is the main version of the page. It is client MVVM is very much something that you will do in the classic ZK architecture, where you have a session object, where your components exist in the session, and where your session drive the client. with client MVVM, you assume that some of the user actions don't really need an update from server side. If the user is running if the user is running a large list box, for example, you don't need the server to tell you what is after the current element. You want render on demand to happen, but you don't need to do a check-in with the server every time you do render on demand. You just have everything already preloaded at client side, and you have your client simply do the update as needed. And with client MVVM, you have a state at client side, which you can send smaller smaller byte of update from your main state, but the main state is still at server side. It's still very much that original ZK. Now the stateless component out of Java and as part of ZK page. So I'm assuming that when you say as part of ZK page, you're talking about Zool. Is that correct? If that's not correct, please let me know. And if it's correct, I'm just going to answer that. So at the moment, there's no plan to have Zool code translate as iComponents because the components themselves have the coding sugar that I was showing earlier, where you can just create them in the shape of a Zool page. So translating those into Zool would simply changing Java declaration to XML, and it would not bring really, in our opinion, it would not bring a lot of value. And from the way the ZK work internally, a Zool page is already an abstraction of Java. When you're parsing a Zool file, essentially what's happening in the background, and as a developer you do not see, is the page parser is going to iterate on everything that is in your Zool page and is going to generate Java ZK component for you in that way. If there is already an easy way to create those components with the Java coding sugar, I don't. That's a personal feeling, but I don't personally feel that there is really much a point in having another way to generate the same element. If that's something that you see benefits that we are not seeing or use case that we are not seeing at the moment, we would absolutely love to hear about that in detail. We're still working with Richard Laploche. We're again in MVC, and you want to decouple component server MVVM. MVVM is going to be extremely difficult to do in stateless, mostly because as a pattern, you want in MVVM to have your view model separated from your view. You want those two elements to be as unlinked as possible. You don't want your view model to know about the ID and the relationship between the components. You don't want your view to know about the data structure that exists in the view model, because you want to be able to take a specific view model and then swap any view that match its functional API. And in the other direction, you want a view to be able to use any view model that match its functional API. In the case of stateless, I would say it's not something you can do without maintaining a state. And so it's really not, if you want to do MVVM in a way, you have to maintain a state in order to pilot the view. If you want to do stateless, you don't have a state. So those have an internal tension that at the current time we're not trying to bridge, because they're different from each other at a fundamental level. Okay, let me pick up the thing I may have missed. Regarding trigger action, do we have to use component IDs? Sometime we have to reuse component and ID is not present. So you need a way to identify where the information that you're looking for is located. It can be component ID, it can be other way to locate that information. I was mentioning earlier that, for example, you can try to locate that information using relationships, trying to find the first sibling of the parent, or trying to find the next sibling would be valid way to navigate in the component tree at client side and then retrieve that data. Because the stateless architecture is workflow based and not state based, you would not be able to keep in memory a specific component at server side in order to reuse it in different actions. What you would want to do is to be able in your action to target in the different part of your UI where each of those information are located. You can do this with complex selector. For the more complex version of the selector, I will again invite you to go look at the shopping cart demo, which is also in the GitHub link that I've provided, because it will contain some of those more complex way to look for attributes, to look for components, and to update them. Okay, let's keep going. Can you use event queue in this architecture? I'm not sure why you would use event queue in that architecture, because event queue essentially means that you have at server side a way to notify different part of your UI or different pages when a specific event happens. In the stateless architecture, you don't work with a state at server side, you work with workflows. You take an action with some input, and then you output something based on that action. But you're not maintaining something that would be notified. At the current time, I don't want to tell you something wrong, so I'm not going to give you a straight answer on can you actually use the event queues, or if we're talking event queues, I'm going to put in the same bag the server push technologies. That's something I will come back to you later after double checking. This is not a use case that has popped up in what I have been testing on the stateless component so far. So rather than giving you wrong info, I'll make a note and I will come back to you later. All right. Is the ID of the component a necessary argument for receiving action? It is not. As I was just mentioning before, you can do relationship, for example, based search. If you have, for example, a text box which is located at one point in your UI, and above that text box you have a checkbox, and you know that you want a property there to be processed at the same time as your text box. You can do self, so current element, previous sibling, in order to retrieve the previous sibling of an element that you've already identified. If you want to retrieve something that is the first child of the current element, you can do that. If you want to retrieve the parent, from the parent retrieve the first child, and then find the next sibling of the first child, you can do that. What you need to do is to be internally consistent. Since you're working with workflow, you need to define in what way you locate your elements, and I will again refer you to the shopping cart demo, which contain advanced uses of those structure. Let's see. with Richlet approach, we're again in MVC, want to decouple. We've already discussed that. A question related to with constraint. In the sample, in the classic framework, this is validated on server side. With Stateless Component, it's only validated on client side, browser side. Would an evil client be able to send invalid data, and you would have to do a manual validation on server side? Is there any simple validator, such as constraint validate component? That's not something I have used in the current state. I would say in any case, you should consider that anything that comes from client side is suspicious by nature, and you would need a validation to happen, either by validating yourself or by relying on a validation workflow that is part of the framework. The question is, can you use a validator that is part of the framework at the moment? That's not something I will have a clear answer. So I will take your information and come back to you a bit later with that answer. In classic architecture, we get a response as Zulfa, but in Stateless architecture, we're just setting up structure and get response from this processor using Java code. Okay, I'm assuming your two messages are linked. How to do session management in stateless, because we need session tracker to maintain an activity logging of user. In this scenario, what solution for text activity? Is it taking previous site? And so, as I was mentioning, we do not keep a state in the stateless architecture. This is the whole point, because keeping that session, keeping that state is what we want to avoid in order to be able to create those independent individual controllers, containers that contain smaller size services. If your application relies on the session object, then, and if you don't plan to use a microservice or hosted container or spinning up container, spinning down container, I would say it is probably not a good architecture for you to use. If you want to keep track of data, I'm going to come back to the code for that, because that's that will be easier to explain with the demo Richlet. If you look at the code in the demo Richlet uses database in order to store the state, because because there is no state object that is permanent between each of the node that exists in our architecture. If something needs to be kept permanently, you simply have to store it in the background in a database layer. From my Docker container, you will see that we have here a Postgre database which is running. That Postgre database is used by the database service, the order service here, which itself will access the database. I think it's running a simple DAO pattern, just creating object and then returning them, which will contain your order ID, which will contain the different items that are in your order, and which are used by the Richlet. Let me just jump to the database order service here. In this case, when the application has to store something permanently, it goes and store it in the database. Okay. Let's go back to the questions. Where did I stop? Well, I'm not going to tell you how you need to track your users. It might be that you have an authentication server that you're doing something using OAuth, and then once you have authenticated the user, you just keep track of their session token, and you send that session token every time you do an action. That's a possibility to do it. It might be that you have an authentication framework around your application, and that you just delegate that to the authentication framework. There's a lot of way to do authentication, and this is not really the purpose of ZK. ZK is agnostic of that. Okay. What did I miss? Is there any question I have not seen so far? In classic architecture, we get response as Zulfa, so we already seen that. As you know, Q use desktop info, which is stored in session attribute. That's correct. So that's why I say I don't want to give an incorrect answer on the event queue today, because it is not something that has come up with my experience with stateless. And keep in mind that stateless is an evolving technology at the current time. I'd rather go to the source and then provide a definitive answer when I have a satisfying answer to give. Okay. Is there, can we use custom constraint inside with constraint? Good question. Let me just check that in real time. Custom constraint. With constraint, this one accepts a string. We have at the moment custom. We don't seem to have that. I would have to double check if that is something that will come up in the future or not. So I will also make a note and come back to you on the custom constraint side of things. Is there any question that I missed? If you have asked a question and you've not received feedback from me, please feel free to re-ask it again if I am not seeing it at the moment. Or if you need to unmute to ask question, now is a good time. I'm going to wait for another 20 seconds to see if we have any question remaining. And in the meantime, if there's no question coming up, thank you very much. If there's no question coming up, I will thank all of you for attending today. I hope this was informative, that gave you more perspective on what we want to achieve with the stateless components, and that it clarified as many as the question you may have had as possible. For people who had a question which I couldn't answer today, I'll be coming back to you by email a short time, perhaps this afternoon or tomorrow. Can you share any YouTube tutorial in English covering basic to advanced topic in ZK? I would have to come back to you because I'm personally not using such tutorials. I would have to check what is available and then come back to you if that's all right. It is, since it's a bit out of the scope of this presentation, unfortunately, I don't have something prepared. Okay, then I think we are all covered. Thank you. Thanks to all of you for being here. If you have feedback, I'll put back the link on screen as well as on the chat so you can easily find it. Please let us know what you thought about all of this, as well as the GitHub link. Thank you very much. Okay, and I think with that, we're good to go. Have a good day, everyone, and thank you for being here today.